Homework 8, number 4. So this is similar to number 3. In number 4, you're asked to write a for loop that creates an array with alternating zeros, ones, and twos with a length of 21. Okay, let's go to MATLAB and try to do this. So I'm gonna start a new script, and in this problem, I want to create an array with a length of 21 that has alternating zeros, ones, and twos, right? So technically I want to create this array 0, 1, 2, and I want it to have a length of 21, so this has to repeat itself 7 times, right? So this is 1, 2, 3, 4, 5, 6, 7. So I want to create this loop. Oh, this array, sorry. So if you remember from number 3, we added this comment, and this is basically the golden rule for these types of problems. So you need to run the counter over the entire length of the loop, but have a step size equal to the length of the repeating segment, right? So I'm gonna run a counter. Let's move this to second line here. Run a counter. So we're gonna run a counter over the entire length of the loop, but have a step size equal to the length of the repeating segment. So in this case, the repeating segment is 0, 1, 2, right? So it has a length of 3. So I'm gonna run a loop from 1 to 21 with a step size of 3. Okay, so let's do this. Let me write CLC clear to clear out the memory when running this this loop. And the vector, or the vector which is going to store the numbers, let's call it A. And this line I'm just initializing the vector. And so I'm running a for loop, we said, from I equals 1 to 21 with a step size of 3. So this is the line loop from 1 to 21 with a step size of 3, which is equal to the length of the repeating segment. And in this loop, again, I'm going to have A of I equal to 0, A of I plus 1 is equal to 1, 1, and A of I plus 2 is equal to 2. And then after I'm done with the loop, I'm going to just display A. So before running the loop, let's try and logically go over this. So initially, A is equal to 0. For the first iteration, I have I is equal to 1. So A of 1 will be equal to 0. A of 2 will be equal to 1. A of 3 will be equal to 2. So this means that my A vector at this stage is equal to 0, 1, 2. And then for the second iteration, I becomes 4, right? Because I have a step size of 3. So I becomes 4. So if I go through the loop body, A of 4 now is 0. A of 5 now is 1. A of 6 now is equal to 2. So my A vector after the second iteration becomes 0, 1, 2, 0, 1, 2. And then third iteration, I in this case is equal to 7, right? Because I have a step size of 3. So let's add this here as a comment. So I will basically loop from 1, 4, 7, 10, 13, 16, right, this makes sense. 1, 4, 7, 10, plus 3, 13, plus 3, 16, plus 3, 19, and then it's going to exit at 19. And then going back here in our planning comments here, third iteration I is equal to 7. So a of 7 in this case is equal to 0. A of 8 is equal to 1. A of 9 is equal to 2. So after the third iteration, a should be equal to 0, 1, 2, 0, 1, 2, 0, 1, 2. And this will basically repeat until I have um, an overall um, array with 21 elements. So let's try and run it and see what we're gonna get. Troubleshoot any errors if we have any. So I'm gonna go up here and click on run. It will ask you to save it. So save it in a place where you can find it. I'm gonna call it homework 8 number 4. I'm gonna save and then add it to path, whatever is needed. And as you can see here, once we run it in the command window, you can see that you get your array with alternating 0, 1, 2, 0, 1, 2 with a length of 21. So um, so if I have A, so your array A or row vector A is just alternating 0, 1, 2 over an overall array length of 21.